Okay, now we're going to do the Webster method. So I got the total population. I took my representatives. I divided my total population by representatives to get my standard divisor. Then I take this 71.31 standard divisor and divide it to all my individual populations to get my standard quotas. My standard quotas, now I'm going to round normally for Webster method. So this becomes 4. This is 5. This is 2. This is 9. This is 14. It rounds up. This is 4. This is 7. And this is 11. Now we're going to add that up. 4 and 5 is 9. 9 and 2 is 11. 11 and 9 is 20. 20 and 14 is 34. 4 is 38. 38. And 7 is 45. 45 and 11 is 56. So now I have one too many votes. Okay, so now I need to reduce the amount of votes I have by 1. The obvious choice is whatever's closest to 0.5. It's this one. And I want to get this one down to 3.49 so that rounds down to 3 and it'll bring me to 55. To get my standard divisor by doing that, I'm going to take my 251 and we're going to divide by 3.49, and that gives me a modified standard divisor of 71.91. And you'll notice this one goes up because I want my reps to go down. It's inversely proportional. When I divide all of these by my 71.91, I get 3.80. I get 4.80. I get 1.95. I get 9.15. I get 13.68. That one drops quite a bit, but still not going to catch the other one. 3.49 it stays. We get 6.80. And we get 10.87. And then we round normally for our final apportionment. That's 4. That's 5. That's 2. That's 9. That's 13. This stays at 3. This is 7. And this is 11. And when you add them up, you should get 55. 4 and 5 is 9, and 2 is 11, and 9 is 20, and 13 is 33, 36. 36, and, I'm sorry, 4 plus 5 is 9, and 2 is 11, 11 and 9 is 20, 20 and 13 is, I'm sorry, this should be 14. Excuse me. Sorry about that. So we have our 4 and 5 is 11, 11 and 2 is, or 4 and 5 is 9, 9 and 2 is 11, 11 and 9 is 20, 20 and 14, because this rounds up, is 34, 37, 44, and we get to our 55. So that means we must be correct. Alright, now we'll move on to the next one that is also Webster method. Alright, so this Webster method, we're going to round normally once again. 11 we get here, 9 we get here, that's 20. And 3 we get 23. And 18 is 41. And 3 is 44. And 5 is 49. 49 and 13 is 62. And 62 and 17 is 79. So we get 79 as our total, so we need to now increase by 1, which means one of these needs to get to 0.5. The most likely candidate is right here. It's the closest to 0.5 and the second biggest, so it's going to move up pretty quickly. So I take that 920 and I divide it by 17.5. When I take that 920 and divide it by 17.5, so that my standard quota for that one would be 17.50, I get 52.57. So this is going to be my now modified standard divisor, 52.57. And we're going to divide each population by that 52.57. We get 11.24. We get 9.19. We get 2.57. We get 17.82. We get 3.40. We get 5.25. And we get 13.32. And we round that normally again. We get 11. We get 9, which is 20. 3, which is 23. 18, which is 41. 3, which is 44, 5, which is 49, 13, which is 62, and 18, which gets me to 50. And that's my standard, or my final apportionment for this Webster method. Finally, we have foiling, which is first terms, outer terms, inner terms, last terms. So essentially, we're looking at this. First terms, outer terms, inner terms, last terms, and then we combine the middle term. So this here becomes 8x squared plus 20x minus 6x minus 15. And then when you combine the middle terms, 8x squared combines to be a plus 14x and a minus 15. Second one, 5x times 3x is 15x squared. 5x plus 8 is 40x. 4 plus 3x is 12x. 4 times 8 is 32. And we combine our middle terms. 15x squared plus 52x plus 32. Down here it becomes 3x times 4x, 12x squared. And then 3x times negative 7x minus 21x. Negative 2 times 4x is minus 8x. Negative 2 times negative 7 is a plus 14. And combine your middle term. 12x squared minus 29x plus 14 is my answer. Finally, 6x times 3x is 18x squared. 6x times negative 7 minus 42x. 11 times 3x is 33x. And 11 times negative 7 is minus 77. 18x squared becomes minus 9x when you combine in the middle, and minus 77. And that's my answer.